Hello everyone, my name is Ishika Koshia, and in this video I'll be walking you through my assignment on detection and convolutional neural networks. This assignment involves applying convolutional operations, understanding model architecture, and improving performance using additional layers and dropout techniques. Let's dive right in. In the first part of this assignment, we explored edge detection using convolutional kernels. A convolutional kernel is a small matrix that slides over an image and performs calculations to highlight certain features such as degrees or lines in a specific direction. To detect 45-degree lines, we used a kernel like this. When applied to an image, this kernel enhances diagonal edges from top left to bottom right. Similarly, for detecting 135-degree edges, we used this kernel. This highlights edges in the opposite diagonal direction from top right to bottom left. After defining these kernels, we applied them to an image of a car and plotted the results. The output showed clear edge detections emphasizing diagonal lines in the image. This displays the graph. Moving to question 3, did the network present signs of overfitting? If so, in which epoch? Yes, the network showed signs of overfitting when the training accuracy keeps rising while the validation accuracy either stops increasing or even begins to decline. This can be seen around epoch 30 when the validation loss started to increase while the training loss continued to decrease. Overfitting took place according to the training history. Question 4. Write down how many layers this model has and identify their types. The original model consists of the following layers. Convolutional layer extracts features from input images. Pooling layer reduces spatial dimensions while retaining important features. Flattening layer converts the 2D feature maps into a 1D array. Fully connected layer, a fully connected layer that makes final classifications. Output layer outputs the final classification probabilities using softmax. Question 5th. Briefly explain what is the purpose of each of the layers. Convocation layer detects patterns, edges, textures from the image. Pooling layer reduces image size while keeping important features. Flattening layer converts the feature maps into a 1D format for the fully connected layer. Dense layer acts as a classifier by learning complex patterns. Output layer uses the softmax activation function to output probabilities for classification. Moving to question 6, we analyzed a deep learning model and examined its architecture. The original model consists of several layers, each playing a key role in an image classification. While training this model, we monitored its performance across 50 epochs. Around epoch 30, we observed overfitting, where training accuracy kept improving but validation accuracy plateaued or started decreasing. This is a clear sign that the model is memorizing training data instead of generalizing well to new data. In question 6, to improve the model, we added an additional convolutional layer to extract more complex features. Here's the modified model with an extra convolutional layer. After training, this improved model showed higher validation accuracy and extracted better features from the images. This is the graph. Question 7. Compare the results between the original model made using Keras, sequential versus the bigger model with at least one extra layer added. Describe what are the differences between them. The modified model with an extra convocation layer showed improved feature extraction. The training accuracy was higher than the original model. The validation accuracy also improved, meaning the model generalizes better. However, the training time decreased due to additional computations. Moving to question 8. Dropout for overfitting reduction. To further address overfitting, we added a dropout layer. Dropout randomly deactivates neurons during training, forcing the network to learn more generalized features. With this addition, the model became more robust, achieving a better balance between training and validation performance. This displays the result from the code. Moving to question 9. Explain with your own words what is the purpose of dropout layer and how it works. According to me, a dropout layer is used to prevent overfitting in neutral networks by randomly deactivating a percentage of neurons during training. In simple terms, dropout removes some neurons randomly in each iteration, which makes the model more robust. It helps the network generalize better, especially when training with small data sets. That wraps up my explanation for this assignment. I hope you found this video helpful. Thank you.